All right, here we got another series problem. Series problem. We're trying to find what x values make this series convergent. This is the x that we're gonna have to work with up there. This is blurry. Okay. So, the series is n equals 1 to infinity. That's like the bounds. I don't know. All right, but it's of on the numerator it's -1 all to the power of n minus 1, and then that multiplied by 3x minus 1 all encased by the power of n. The denominator is n times 2 to the power n. Right? And to find which x values make a convergent, we're always going to use the ratio test. And ratio tests have absolute value signs, so we could actually just disregard that. I was going to write that, but nah. And remember that we start off with n plus 1 for every n in the ratio test. And then we flip it, and leave n's the same. Right? And these 3x minus 1 to the power n's both cancel. But remember, it leaves another 3x minus 1 because of that 1. And then the 2n to the power n's cancel. But don't forget about that 2, the extra 2, because of this exponent. This pen's fading. I'm just putting them in a way I like it. The ends combined, the non-ends combined. We could actually take this non-end part and bring it out in front of the limit or behind it. I don't know, just like to the left of it, because the limit uses bounds of n, or like n is the variable, and it's not like related at all. This is just a constant, I guess. I think, hopefully I'm saying that right. We could actually take off the absolute value sign for this little portion, because as you can see up here, n is from 1 to infinity, so it's only positive numbers. So yeah, we could use parentheses. All right, and to whittle this down, we could, okay, let's just say, because we're going to infinity, this is an n, by the way, I wrote that bad. Since we're going to infinity, that 1 is going to become irrelevant. So we could kind of just plus 1 won't do anything, really. So we kind of just like don't care about that. And then n divided by n is equal to 1. So I'll just write it out. And since there's no n, this limit kind of goes away too. Doesn't do anything, so it's 1 times that, which equals, well, that's a 2, by the way. Gotta get a paper holder. Alright. Okay, so we have this 3x minus 1 over 2 all in the absolute value sign. Since the x can go crazy, it could go negative. There's -1, something crazy could happen. So we leave the absolute value sign for that. And remember, using the ratio test, we have to have like the final result. In this case, it's this chunk I'm encircling with my finger. And this result has to be less than 1 to be convergent. So we just set up the inequality. All right? And now we can multiply 2 on both sides. And here we could divide by 3 on both sides to get the x, like not multiplied by anything. Well, that's 2, by the way. Paper holder's gonna have to shift to this side. Wow, wait, hold up. There we go. And then we can take out the absolute value. Okay, remember what you see here, because I'm gonna flip the paper, because we're kind of, oh no, we got space over here. Flip, okay. We could take out the absolute value and just bring in the negative version, so negative 2/3. Okay, I'll say what I'm writing. I'll block that side off. So this is negative 2/3 is less than x minus 1/3, which is less than 2/3. Now if we add 1/3 every side, we have negative 1/3 is less than x, which is less than 1. So the bounds, okay, I'm not gonna check the bounds. It could include -1 or negative 1/3 and 1 in this equation. Like if you plug in negative 1/3 or 1, it might make it convergent, but I'm not gonna check because this video is 7 minutes long, and if I flip the paper, it's kind of yucky. So the values are for sure in between negative 1/3 and 1, whether they are included, which is determined by like a bracket, or not included, which is determined by like the parentheses, is, I don't know, I honestly don't know, kind of just winging it. But it's for sure the numbers between that makes the series convergent, so that is what x equals.